Okay guys, so we are going to look at example 4, we did not get to in class today, the Atwood machine from your guided notes. So when two objects of unequal mass are hung vertically over a frictionless pulley of negligible mass, as shown in the figure, the arrangement is called an Atwood machine. The device can be used to find the acceleration of gravity. What we want to do is determine the magnitude of the acceleration of the two objects and the tension in the string also. So you want to find the acceleration, the magnitude of that, and the tension in the strings. So looking at our little diagram here, we want to construct two different free body diagrams for one for each object. So let's start with mass 1. So we're going to do a free body diagram for mass 1. You see that? Yeah. Okay, so we're going to represent the object using a point, draw the forces, act on the object. So the force of gravity, M1G. And T, the tension in the rope. I'm going to make this a little bit smaller so that I can fit some of the calculations all aboard. Okay, next we need to assign direction. So according to our diagram and the shapes of the objects, we can figure that M1 is going to accelerate upward. So we're going to assign up to be positive and down to be negative. Great. Free body diagram number 2. So let's look at mass 2. We have the same two forces acting on our object. Right, force of gravity, M2G. We have tension. In this case though, right, we think that the object is going to accelerate downward, so we're going to assign down to be negative and up to be positive. Why does this make sense? Because our tension, right, we know they have the same magnitude, but they're going to be opposite directions. Which they are, right? T for M2 is negative, the tension for M1 is going to be positive. Okay, so drew our free body diagrams, assign direction. Now we want to sum the forces, and solve. So we want to sum the forces for M1 first. Technically, in which direction will M1 accelerate? In only the y direction. So we're going to sum the forces in the y for M1. So under the second law, F equals ma, sum of the forces in the y direction is going to equal m1 times the acceleration, which will be the same for both masses, again in opposite directions. So in the y direction for m1, we have the force of tension, positive, pointing up, the force of gravity, negative, pointing down, according to our frame of reference. So we're going to have T minus m1g is equal to m1 times a. Good. So what we're going to do next is you want to look at our second object. We're going to sum the forces on M2. Sum of the forces in the y is going to equal M2 times A. In the y direction, we still have our tension here, and we have force of gravity, but tension is negative. Gravity is going to be positive. So we're going to have M2G minus T. is equal to M2A. So we have two equations, we have two unknowns. We're going to use substitution to find acceleration and tension. So it's up to you which one you want to solve for first, whether you want to look for the acceleration, then the tension, or tension first, acceleration, you're going to get the same answer. What I'm going to do up here is I'm going to solve our equation 1 for T, for tension, and then plug it into equation 2. Okay, so I added that other value to the other side of equal sign to get T by itself. I'm now going to plug the tension in to equation 2. If substitute it in there. Okay. Alright, so I plugged in this entire quantity for T. Don't forget to distribute that negative sign. Okay, so now we only have one variable in this equation, right? We eliminated T. We're going to solve for acceleration. So I'm going to add m1a to the other side of our equal sign. You'll see that we have two a's here. We want to get them by themselves. So we're going to take that a, we're going to factor out that quantity. Oh, as you see here, right? So I added this to the other side. It should be M1. I've changed it to M2 because I moved it to the other side. So make sure you go back and correct that. So last line, right? M2G minus M1G is equal to M2A plus M1A. You factor out the A, so it's going to be A times M1 plus M2 is equal to, we're going to copy down this line, everything we have on the left side. We're going to divide both sides by the sum of M2 plus M1 to get A by itself. We rearrange, we left with A equals M2G minus M1G divided by the sum of the masses. Okay, so now we can plug in for A. I'm going to pause for a second and plug those numbers in. Just kidding, there are no numbers, it's in terms of variables, so that is our answer, that is our quantity for A. We're only halfway done, right? So the magnitude of A, we need tension. So we're going to plug in that whole quantity for A back into equation 1 over here so that we can find tension. So equation 1, we're going to plug in that quantity for A. So T equals M1 times A, which is M2G minus M1G divided by that sum, M2 plus M1. And then continue with our other equation, M1 plus M1G. So there we go. So we could technically simplify this a little bit. For the sake of this example, typically we'd have numbers. For the sake of this example, that would be your final answer. But typically we would have numbers, so we would plug in those numbers to solve for the tension, the same way that we've been doing examples in class. So now you should be able to do number 28 on your homework. If you have any questions, please send me an email or ask first thing tomorrow in class. Great, see you tomorrow.